Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 17th November 2023. The problem statement for today is binary tree to CDLL, and this has been asked in Amazon and SAP Labs interview. Let's now open this problem to solve it. Let's go through and understand the given problem statement. Here it says, given a binary tree of n edges, the task is to convert this to a circular doubly linked list, which is referred to as CDLL in place. The left and right pointers in the nodes are to be used as the previous and the next pointers respectively in CDLL. The order of the nodes in CDLL must be same as in order of the given binary tree. The first node of the in-order traversal left, that is leftmost node in BT, must be the head of the CDLL. Okay, so the problem statement here it says that we need to convert a binary tree into a circular doubly linked list, which is called as CDLL. Okay, and this should preserve the order of nodes according to an in-order traversal of the given binary tree. The CDLL should be doubly linked list, both the left and right pointer, and it should be circular, meaning the the last node should always point to the first node. Okay, so this is the problem statement. Let's go through the given examples here. So here the first input says this is the given binary tree. So here and we have to convert it to a doubly linked list. So here it will be like 3, 1 and 2, because we have to follow the in-order traversal. So if you follow the in-order traversal of this binary tree, so first it will be 3, that means left, then root, then right. So 3, 1 and 2. And since we are using doubly linked list, it is even expected that even it should print the answer in the reverse order. So that's why the output here even it says the reverse order of this one, which is 3 2 1 3. That is exactly the reverse of the first one. Okay, so if you look at the second example, so second example here it says this is the given binary tree. So if we do the in-order traversal of this one, so first from the root we add it to the leftmost subtree, and from there we again follow the same approach, left subtree, root and the right subtree. So here we get the leftmost node is 40, then 20, then 60. So same is here, then 10, and to the right of that this 10, one subtree is there that is containing the element as 30. So that is coming here, and if we have to print the reverse of it, so the reverse will be exactly the opposite of it. Okay, so these are the two given examples here. So if you try to solve this problem, so here to convert the binary tree into CDLL in place, we can perform the in-order traversal as it is mentioned in the problem statement of the binary tree, and we will modify the left and right pointers of each node to form a circular doubly linked list, which is called as CDLL. So let's see how we can do that. So we have taken the first example here. So let me just, I hope it is visible. Okay, so here this is the binary tree we have taken, the first binary tree which is given in the problem statement. So here we have taken that example. So this is the binary tree. So here we have taken two pointers, that is left and head and tail, and both are pointing to null initially. So initially what we will do, we will take the we will iterate to the leftmost subtree, and here first we will start with the root node 1, then we will process with the left subtree, then we will reach 3. Okay, so starting with this root node as 3, process to the left subchild. We do not have any left subchild here. Then what we will do, we will set head to 3 and tail will still point to null. Then connect, we will make tail dot right to the current node, which is 3, and set 3 dot left to null. Okay, and we will update the tail to the current node. Okay, and after that we will process the right subtree, but again to the right of 3 we do not have any child, so our tree will be looking like this. Okay, and actually here tail will be even pointing to here 3 only. Tail will be pointing to 3. So left 3 dot left will be pointing to null, tail will be pointing to 3 and head is again pointing to 3. So here it will be even head will be pointing to 3. So both head and tail will be pointing to 3 here. Okay. So now after that we will move back to the root which is 1 here. Then we will then after that we will do and the tail dot right to the root node which is 1 here, and we will set 1 dot left to 3. Okay, and after that we will update tail to root 1. So what exactly we will do here? This one. Since we have moved to back to this one, we will make tail dot right, because tail was pointing to 3. So 3 dot right, that will be pointing to 1. Okay, so we will get this pointer, this direction. That means here tail was pointing to 3. 3 dot right will point to 1, and 1 dot left will point to 3. So 3 dot right will point to 1 and 1 dot left will point to 3. So here we are getting the two-way link established. Okay, and after that we will again update tail to root node 1. Then we process with the right subtree, and we start with the root node 2 there. Then we try to process again as we did for the left child. We try to do with the right child. We try to process the left subtree. We do not have any subtree there. Okay, then what we'll do, we will do connect tail dot right here. Tail dot right we will set to 2, because tail was pointing to 1. So 1 dot right will be pointing to 2 and 2 dot left will be pointing to 1. And again we will move left this tail pointer to 2. We will point this tail pointer to 2. So it will be like this. So after that it will become like this. The 3 left of 3 it will be null, and right of 3 it will be 1, left of 1 it will be 3, and similarly between 1 and 2, two-way connection established, and again tail will be pointed to 2. So after that we again see we do not have any subchild left. So now till this point we have established the doubly linked list here, but we have to even make it circular. So after the in-order traversal is done, heads point to the leftmost element which is 3, and tail points to the rightmost element which is 2 here. So again head will point to this 3 and tail will point to this 2. Then what we'll do, we'll connect tail dot right to head to make 2 dot right is equal to 3. So if we establish connection between tail dot right and if we mark it with head, so it will be like 2 dot right it will point to 3, which we have done here, and similarly 3 dot left we will mark it with 2, that is equal to head dot left will be pointing to tail. So that will be again equivalent to 3 dot left is equal to 2. So at last the resulting circular doubly linked list will be 3, 2 and 1, and 2 will be pointing to here 2 will be pointing to 3 and 3 will be pointing to 2 here. Okay, so I hope then this is clear. So this way we will approach, and so whatever the steps I have written here, same we will write in the form of Java code and subsequently C++ code. So let's move to the coding editor again. So here we'll first go with Java. So here I have prepared one solution. Let me try copy it here. I'll remove this complete part and paste it here. Okay, so here whatever the steps I have shown there in the algorithm, the same I have written here. So what exactly we do here, if we look at this complete algorithm, so we start with this method. Okay, and we have two global pointers, like global pointers means here I have added it before the method call. So two global pointers, head and tail, are initialized to null. These pointers will be used to keep track of the start and the end of the circular doubly linked list, which is the CDLL which we are trying to form. Okay, then we have this main conversion function. This function is responsible for initializing the head and the tail pointer. This will be to null, and then we will call one helper method, which is btree to circular list util. This method to perform the in-order traversal and convert the binary tree to CDLL, and finally connecting the last node to the first node and to make it circular. Okay, so we will call this method and we will get the doubly linked list. So after that we will point head of left to tail and tail dot right to head to form the circular. So same comment I have added here. Connect the last node to the first node to make it circular. And after that is done, we are returning the head pointer. So that will again start with the starting of the doubly linked list. And when we look at this helper method, so this function is a recursive helper method to perform the in-order traversal of the binary tree. For each node encountered during the traversal, some steps are getting performed. If the tail is null, it means this is the first node encountered in the in-order traversal. In this case, set the head pointer to the current node. Okay, so here we are setting the head pointer to the current node, which we have passed it in the form of root here. If tail is not null, that means the else block. So it means the previous nodes have been processed. So connect the right of the previous tail node to the current node and set the left pointer of the current node to the tail. So we are making the right pointer of the tail node to the current node and left pointer of the current node to the tail. And after that we update the tail to the current node, which is the root here. Okay, and we call it recursively. I hope this is clear. Then once that is done, then again as I explained here, once this in-order traversal is complete, then the last node process till tail is connected to the first node head to form the circular doubly linked list. The right pointer in the last node tail is connected to the first node and the left pointer in the first node, that is head, is connected to the last, this one. Okay, and we return the head pointer as I have explained earlier, which is now pointing to the start of the circular doubly linked list. Okay, so in this approach, if we look at this complete program, in this approach the in-order traversal we are using to visit each node in the binary tree, and during this traversal it connects the node to form a circular doubly linked list. The global pointers which we are using here, which is head and tail, are used to keep track of the start and the end of the list. And at the end of the traversal, the list is connected to make it circular. Okay, so this is the complete solution for this problem. Let's try compiling this code. So here we can see we have got correct output for this given sample. Let's try submitting the solution. So here we can see we have got all the test cases covered here. So when we look at the time complexity of this solution, it is in the order of big O of n, where n is the number of nodes in the binary tree. Okay, so the first this util function is there. It performs the in-order traversal of the binary tree, visiting each node exactly once. For each node, some constant time operations we are performing here, like updating the head and the tail pointers, and we are connecting the nodes. Therefore, the time complexity is proportional to the number of nodes in the binary tree, resulting in O to the power big O of n time complexity. Okay, so this was the Java solution. So let me move to C++ code. So even that solution I prepared. The logic is completely same. The syntactical difference we find that is only there. So here we are starting with this. I'll replace this part. So again same thing, we have two pointers here, then we initially point to null, we visit this, we call this helper method, we get the tree in the doubly linked list form, then we connect the ends to make it circular. And similarly here in-order traversal is done to make the doubly linked list. Okay, let's try compiling this code. So even with this we have got the correct output. Let's try submitting this solution. If you can see, I have added comments here as well so that it becomes self-explanatory. So even with C++ code, it has covered all the test cases. So this problem has been solved successfully in both C++ and Java language. So I'll provide the link for this question and the link for the solution code in Java and C++ in the description box. Please do check that. That's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.